Today, I just opened a new file here. What we're going to do is start with EDA. So this is pretty standard practice in any of these type of projects in data science, where it's the exploratory data analysis. Within that realm, what I want to talk about is you have multiple options. So you can be a Pythonista and run everything through Python. You can be an Excel power user and run everything through Excel. Or you can be tool agnostic and just use whatever suits the case for you, because our goal is actually time series modeling, not Pythonista, not Excel power user, not business intelligence user, etc. So I want to give a couple options here. First, I'm going to do a real quick demo of some EDA in Excel, and you'll just see it's real quick, real fast, real dirty. Python will take a little bit longer to script. Maybe some Pythonistas just much faster at coding, so they'll probably put it together faster. My actual that I would prefer to use, but I'm on my home computer here and I don't have these here, would be Tableau. Tableau is probably my favorite EDA tool. This is my daily driver at work, at least. I really like Tableau a lot. The alternative to that would be Power BI. So Power BI is free. You can install it on your desktop. I use it a lot. I like it. Mine would be Power or Tableau if I had an option though. But I have an alternative to this that I'm going to show at the very end. So what we're going to do next is I'm just going to jump into Excel. We're going to review that file, the combined file, and then we'll look at some EDA, then we'll do some Python scripting, and then we probably, if time permits, get into some of the stationarity of the data and checking to see what we're going to do for as far as differencing or making the data stationary. There's going to be a few methods we'll apply there. So let me open up the Excel file. And here we go. So now everything's open. So I just want to show this because it's super fast what we can do here. So the first thing I want to look at is let's just look at some correlations, then we'll do some plots, some visuals, etc. So here I'm going to go to data, and I'm just going to go to data analysis. So I'm just going to go to correlation. Now in my correlation, in the range here, I'm just going to select from B1 to M, which is the last column here, 415, because that's the shape of my data. My label, yes, the rows are in the header, and I just want to put my output range right here in O2. So we hit OK, and wow, that's super plug and play, super fast. We have now our correlations between our data sets, and the one we're looking at is the S&P 500 adjusted close, right? Let's just go to the home screen. We'll do some conditional formatting. We're going to highlight the cell rules greater than, let's just say we want to look at a correlation arbitrarily greater than 0.5. Okay, so we'll do the same thing again, and let's look at correlations that are less than negative 0.5. Oh, actually, I didn't fill the first one red, so let me go back and do that again. So greater than 0.5 should be green. Okay, this looks good here. So down here at the adjusted close, we can just take a look and say, oh, well, we have a positive correlation between the adjusted close and the industrial production. So when we start plotting these, I expect to see this one run really close in tandem with this one. And what's curious is, okay, we have a 0.97 correlation between the housing starts and building permits. So this one's also going to run really close. And the other interesting thing is I'm looking for negative correlations as well, because I want to look at inverse relationships and how those are going to be modeled with the data. So cool, here's some correlations, but as most people probably know, correlation does not equal causation, so we have quite a bit more work to do. So just in the same vein, I'm going to go ahead and just create a couple charts here just to show for simplicity. Let's just click recommended charts, whatever, this one's fine. And now we have some charts. And I'm illustrating this to show, wow, this is just fast, it's easy. There's not a whole lot of work I have to do here or programming. And for me, what I want to do is let's go to change chart type, and I want to go combo. And here the S&P 500 is what I want on a line chart. So that's on a line, and I want to look at stuff like, well, there's the yield curve, and we could just look at the yield curve first. Okay, I put that on a secondary. I also would like to see the recession on a secondary, and let's just hit OK. And that got incredibly busy. It looks horrible. So let's just select data, and let's take some stuff out that we don't really want to look at just yet. Doesn't really matter. Let's take a lot of this stuff out. So this is kind of neat just to take a look at the visuals. I'm not going to like unpack this too much here. You can really explore this more if you'd like, but I'm just showing the point. We have a dual axis, and now we can see, okay, what we're looking for in our yield curve is when it goes negative. So if it's below the 0 line, we'll see it dip down here, and then we want to see the impact to the S&P. This is our recession, we know that, and so on and so forth. Building permits are here, probably should remove those, and I can just run everything in a line chart, and it's a little easier to see. So this is just one method for exploratory data analysis. We're going to do quite a bit more once we actually get into breaking down the seasonality tests using statistical tests. But for illustration purposes, you guys see that took like no time at all. So now let's do the painful piece. This is going to be a little bit of a struggle. We got to bring all this into Python. So start with import pandas as PD. I'm going to import IO. And the package that I'm probably going to use for this is going to be Bokeh. This is why I installed it. It's just because I'm not a huge fan of matplotlib, and it doesn't have any hovers or interactivity. See, if you use Tableau, you have all that built into, and it's point and click, so super fast. So from Bokeh, what I'm going to need are plotting. So we'll do plotting, and we'll import figure, show. We'll do output notebook. Since we're going to run an interactive notebook here, we're going to need a lot of things from Bokeh, actually. Now I'm thinking about it. So Bokeh, we'll do layouts, because we're going to run into problems with the secondary access. All right, grid. I think we'll do models, because we're going to need our hover tool. Is it under? Yep, there it is. Let's do from Bokeh.io. Let's import push notebook. Then we're also going to import math. I'm going to import Py. One more Bokeh package that I think we might need is going to be. Oh, that's really bad practice, what I'm doing right here. So do as I say, not as I do kind of thing. We'll do linear access. Basically, I'm doing models twice, so you could just put all these here, but we already came here, so let's just finish this up. Let's do range 1D. And then I'm going to import this. This is going to be the fun one. Pygwalker is really slick. I just discovered this actually, I want to say relatively recently, maybe a year and a half ago. So it's a really cool tool. So the first thing is we need to bring in our file. So we have our CSV. The one we just looked at was the combined.csv. And now in this CSV though, I think if I'm not mistaken, we need to parse the dates here. So let's do dates. Because if we're going to run correlation, they can't come in as an object, so we have to make them a value, a numerical value. So I'm going to put a note here for that. So convert all data to numeric. All right, so converting all the data to numeric. So what we're going to do is just do for call in df.columns. And we want to change this to numeric. So now we should be almost off to the races here. And we'll just add in a check. So we'll say errors equals. Perfect. All right, so looks like this is going to be pretty good here. Now, just for the sake of this, we should drop any leftover null values. We shouldn't have any, but just in case. So we'll just add a note. That's good practice. So drop any NaN values. So df.drop, and we'll just say NA. We'll call out how equals any. And then we'll also say we need to in place equals true. And the next thing is, let's just go ahead and check we'll just say descriptive statistics right off the bat. So this is pretty easy in Python that we can just say print df.describe. And we'll go ahead and check that. So I'm going to first run this in an interactive window. All right, let's see what it looks like. Now the interactive window is really good, but downside is this. So this, it's not the most readable for me. So let's just run the file down here. Look at the output from here. Okay, so this is good for me. Looks like 50% of the data for the unemployment rate 5.4, Fed fund rate 2.39, et cetera, et cetera. So these are just good checks. Like over the historical, there's a thing called reversion to the mean, and so what I would expect to see over the lifetime of some data set within the economic realm. Unemployment rate at 5.4 seems a little bit high, so we probably encounter quite a few recessions within this data set. Yield curve 1.54, Fed funds rate 2.39, and you can make assumptions from here saying, oh, that's probably a target point. They want to be within this realm. So we can also say average, so on and so forth, and standard deviations. So this just gives us some of our descriptive statistics. So now we're going to do something a little messy. Let's go ahead and first create our correlation matrix. So the same thing we did in Excel, and we'll do it here as well. But we're going to do a couple ways. So we'll do an output file first, and then we'll plot it. So this is where I say it's a little more time consuming, but if you just prefer to stay in Python, then, do you and stay in Python. So let's do correlation and underscore matrix. And let's do equals df dot, and this is really actually pretty easy. They made this, all the packages are really nice in here. So we have correlation, df correlation, and now we just have to call print the correlation matrix. So same thing, we can run interactive, and I will be running all the interactive for the output graphs at least, just because it looks really nice here. So then also I want to run this file just so I can take a look at the bottom. All right, so here's the same matrix. We looked at something similar in Excel. We expect to see kind of the same data. So here it runs the same, so we can see date to date is 1, unemployment to unemployment is 1, so on and so forth. So tomato, tomato, Excel to Python. Now, what if you wanted to plot this with some visuals and make it look a little bit better? So let's just add a note here and say we want to plotting our visuals for, and I'm going to close this off just because we don't need that for now. This is probably going to be a bit rough. Let's do core underscore, oops. Let's first make our title, and the title, I guess I don't really care. We could just say correlation matrix. And here, let's go to our x underscore range. If I could spell. This is going to be a list. And we'll say df.columns. And let's provide the column range here. So I'm just going to say 1. And now let's do our Y range. It'll be the same thing. So we can almost rinse and repeat and just copy paste, so to speak. So df columns once again. And then we'll do the exact same thing essentially. Let me make sure I'm expecting to get some errors, and I'm not going to edit them out. I'm going to leave them in just to be somewhat real with this. Let's do .image. And in the image, let's do image. And I want to do equals. It would be really good if I could type correctly here. Correlation, and we'll do values. X equals 0, comma. Trying to think about how to best put this together. Let's do df dot columns. I'm looking for palette, I guess. Oh, we are going to get it. Okay. And let's do spectral. Nope, it's not going to call it. Okay, so I think we look good here. Let's go ahead and run. Okay, we got an unexpected error here, so let me take a look at what this says. Oh, I must have typed something wrong here. Oh, I put DG. So this looks good for our correlation plots. Now let's go ahead and build out some line graphs, which these ones are going to get. This is going to be quite a bit more work here. So at first I was a little concerned. I got this error and then I was thinking I got lost. So I paused the video and then went and took a look at it. And yeah, it's a permission thing, but what we can do is actually just click here and I can just run the file and then it's going to open in a new window essentially. So here's the plots and Bokeh is really nice. It's interactive, so we can see this interactivity here. Um, it looks like not everything got picked up on the secondary axis here. So yeah, I need to probably do some revamping, but the whole point was I think that was like I'm hopefully sped up the time if you're watching this. But it took a little bit longer than I care for it to take. So essentially, we do have some nice interactive plots. Bokeh is really nice. We have our correlation matrix heat map. So we have the figures, we have a heat map supporting, but now let's go ahead and go back to here. So there's another thing in here that I think is just probably, I, I'll just say, this is money. I think this is a really cool thing. So at the top here, what you saw we brought in was Pygwalker. I think this is like one of the slickest tools now. So if we can say something like walker equals pyg.walk, and let's just bring in our data frame. So if I comment most of this out, so comment this out, and now let's go ahead and run this. This is slick. So I'm going to run this in a current window. So I hope you can see this. Let me make the screen a bit bigger. So this is slick. I really like this a lot. So here's our field that has our numerical and number fields, measure names, etc. So date is going to be our object. So if you haven't experienced Tableau, well, this is a lot what Tableau looks like. So we just grab date, right? Let's put this in our x-axis. Let's go ahead and put our adjusted close and our y-axis. Wow. Now we have an interactive chart. See, here's our sum. So date close. And you can just play with this. So there's a lot of things you can do in here: tables, pictures, exports, etc. You can throw something else in measure values. So if you wanted to bring measure values all the way across, you can start bringing things in and doing comparisons, overlapping. This just gets slick, and you can change the chart type. So I wanted to introduce this as another method for exploration and data analysis. I think this is one of the cooler ones here. Like, we don't have to sit here and code. I just wrote 2 lines, and now I can start exploratory data analysis. So this is the Pygwalker. So pip install Pygwalker, and then you have like we'll say like the poor man's Tableau or an open source Tableau. So that's going to be it for this one. This video turned out a little bit longer than I anticipated. So the next one, we'll work on the actual time series, check for stationarity, and then make the adjustments to the data that is not stationary and walk through some of the in-depth statistics and then continue modeling.